Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is another video in a review of solving equations for college algebra students, or those students who are entering into college algebra. Now, this video is a little bit of a non-review. In fact, I think that a lot of students who go through elementary and intermediate algebra do not really have this fundamentally important definition for the absolute value function. So even though I call this a review, it technically probably is not. That's because a lot of instructors do not cover the true definition of an absolute value. A lot of students think that the absolute value just makes something positive, but there's more to it than that. The absolute value function is a piecewise defined function. It takes whatever you plug into it, which I use this cute little happy face, the absolute value of happy face. Well, if happy face was already positive or non-negative, there's no need to use absolute values, and so you could just remove those absolute values. If, on the other hand, happy face was negative, well, because it's negative, and you as a student saying the absolute values make everything positive are absolutely correct, actually. It does make everything positive, but if you don't know what's inside the absolute value other than to say that it's negative, then all you can do is say the absolute value is going to take the opposite of that negative number. The opposite of a negative is a positive. So those are the two conditions or cases for an absolute value function. Again, in yellow, if whatever you were plugging into your absolute value was already positive, erase the absolute value signs. If what you were plugging into your absolute value was negative, well, remove the absolute value signs, but put a minus in front of that stuff you were plugging in, because that will force that negativity to be positive. And that is, folks, the true definition of the absolute value. That will pay you back several fold as you move through mathematics, specifically into calculus. Now let's see how this gets used as we solve equations. Let's go ahead and solve this absolute value equation. -2 times the absolute value of 3x minus 1, then minus 5 is equal to -11. You do what you would normally do in mathematics. You start isolating the expression involving x. So I'm going to go ahead and add 5 to both sides, and then divide both sides by -2. Something I want to say before I continue here. When you are working with absolute values, and I said this in one of the videos I just recorded and posted up about the 30,000 foot view of solving equations, what you would do in general. When you're dealing with an absolute value and you get it down to absolute value of something is equal to a number, you want to make sure that number on the right hand side there is not negative. So the number on the right hand side here is +3. That means that we probably do have a solution to this equation. If it was a -3, then we could just stop and say there's no solution to this equation because absolute values never return negative numbers. But that's not the situation we have here. But that's a fast way to just get to a solution without doing any further mathematics. Is if your right hand side is negative here, then you're done. But like I said, here it's not. So what are we going to do at this point? Do you happen to know what x is? That's a rhetorical question, but I'm just asking it anyway. Do you happen to know what x is? No, you don't. If you knew what x was, then you'd be done, right? So if you don't know what x is, then you don't know if this picture in here is positive or negative. You have no clue. So you break this into two cases. By definition, the absolute value of 3x minus 1, well, we could totally tear off the absolute values if 3x minus 1 is not negative. If 3x minus 1 wasn't negative, there's no point in having absolute values on there, and we could just say it's 3x minus 1. If, on the other hand, 3x minus 1 is negative, then we're going to force it to be positive by taking the opposite of 3x minus 1, and that will force that picture to be positive. So when solving this equation, because you don't know what 3x minus 1 is, you don't know if it's positive or if it's negative, we are going to have two cases. Case 1, where 3x minus 1 is not negative, and case 2, where 3x minus 1 is negative. Well, in the first case here, if 3x minus 1 is not negative, well then, going to this equation right here, I'll just rip off the absolute values and solve 3x minus 1 is equal to 3. And we get that solution, x is equal to 4/3. On the other hand, what if 3x minus 1 was negative? Well, we can remove those absolute values, but remember, according to the piecewise definition, if 3x minus 1 is negative, then when we remove those absolute values, that left-hand side of this equation right here is going to turn into a negative 3x minus 1. That's using the true definition of the absolute value. I'm just going to go ahead and multiply both sides by -1. And a lot of students learn this when they're solving absolute value equations. They just know, oh, I'm going to solve 3x minus 1 is equal to positive 3 and 3x minus 1 is equal to negative 3. But they don't know why they're doing that. Here is exactly why you're doing it, because the absolute value turns 3x minus 1 into itself, 3x minus 1, or the opposite of itself. And that's why you get the plus or minus 3. Anyhow, solving this out, I'm going to add 1 to both sides and then divide both sides by 3. Now I know I've done my mathematics correctly, so I don't have to check my solution here. If you want to check your solutions, you're more than welcome to, but there was only one simple restriction on an absolute value equation, and that's the output must be positive, and luckily it was to begin with there, so there's nothing else I need to do. The solutions are 4/3 and -2/3. The final example in this video on solving absolute value equations is a little more robust. I say this is robust because of the fact that it's an absolute value of a quadratic equaling 5x plus 12, but still the name of the game doesn't change. That absolute value of x squared plus 4x turns into one of two things. Well, if x squared plus 4x was already not negative, there's no point to have absolute values on there, and we could just trade out that picture for x squared plus 4x. If, on the other hand, x squared plus 4x is negative, the absolute value will take the opposite of it to force it to be positive. So there are two cases. We're going to go ahead and split this into those two cases, and we'll deal with the positive case first. So the positive case is just going to allow us to remove those absolute values. So we're going to solve x squared plus 4x is equal to, and the right hand side is 5x plus 12. This is a quadratic equation solving. This tells us we have two possibilities, x equals 4 or x equals -3. Now here's the deal. This is why I think that this problem has a little more complication than the previous problem that we did. Normally you would not have to check the answers to an absolute value equation, with one exception. This absolute value right here is not equal to a constant. It would be different if this absolute value is just equal to 12. Then I know whatever answer I got, it would be correct. But because it's equal to 5x plus 12, that right-hand side might be negative. And so we do have to check our answers just really quickly. So from that first case, we have two possibilities, 4 or -3. Checking x equals 4, is the absolute value of 16 plus 16 equal to 12 plus 20? The answer to that is totally. They're both 32. So yes, that works. What would happen if we plugged in -3? Is 9 minus 12 in absolute value, which is, by the way, -3 absolute value would be +3 on the left-hand side. Is that equal to a -15 plus 12? The answer to that is totally no. Absolute values will never equal a -3. So I can throw out the -3 solution here. I'll keep the +4 solution. Now I go ahead and move on to case 2. Since x squared plus 4x in this case is going to be negative, then I know I can take the absolute values and rip them off, but I'll trade out those absolute values for the opposite of x squared plus 4x. And then I just fill in the right-hand side, which is 5x plus 12. Distributing, and now I'll collect everything over to the right-hand side, and I get to this answer right here. Now this is a little bit of a pain as well, mainly because that is not factorable. Two numbers that multiply to 12 and add to 9 doesn't work, so we're going to have to use the quadratic formula here. Remember, the quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Cleaning that up, you get down to this, and a little extra cleanup, we get down to here. Now notice that solution is irrational. Doesn't mean it's wrong, just means that it's an irrational solution. That's okay. Checking that is not going to be entertaining at all. This is one of those rare moments in mathematics where I think just grabbing a calculator and computing this out really quickly is okay. I'm not a huge fan of using calculators that often, but I've done this style of problem before. I could totally tell you it's a waste of effort to sit here and go through and square things out and all that fun stuff. Just grab a calculator. Now, when you try both of these, I'm going to tell you right now, the negative, the minus sign right there, is going to give us a fraudulent or extraneous solution. And that's mainly because that's an incredibly negative number. And when you multiply that incredibly negative number by 5 and add back 12, it's still negative. And so that will never be the result of an absolute value. That's just using a calculator very quickly. I can throw that out. And then the other one actually did work. So I'm boxing that up. It's actually a great example to showcase when you should use a calculator and when you shouldn't. The vast majority of the time, you really shouldn't. But something like this, it's just a waste of time trying to go through and square things out and all that fun stuff. In the end, you have to grab a calculator to figure out how numbers compare anyway. So just faster to use a calculator here. If you're one of my students and you're thinking, well, wait, how do I know when to use a calculator on an exam or not, or a quiz or not? If you need a calculator, I would provide one on the assignment for you, on a quiz or an exam for you. That's how you would know. All right, that pretty much finishes this video out, and we'll do one more video in this review of equations series next. I'll see you there.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.